In this video, we continue to the next example. A survey of 2,318 adults in a certain large country aged 18 and older, conducted by a reputable polling organization, found that 423 had donated blood in the past 2 years. Our goal is to complete parts A through C below. Question A. Obtain the point estimate for the population proportion of adults in the country aged 18 and older who have donated blood in the past 2 years. For the point estimate, this is the sample proportion or the sample fraction of adults in the country aged 18 and older who have donated blood in the past 2 years. That will be represented by P at, and it will be out of the sample size. The sample size is the number of adults in the survey, 2,318. How many of them out of this 2,318 adults, how many have donated blood in the past 2 years? 423. So this is the sample proportion or the point estimate. So with that concluded, if we like, we can always round this off to a number of decimal places. So I have 0.1825 if we want. If we decide to take it to just 3 decimal places, this will be 0.183. Then question B, verify that the requirements for constructing a confidence interval about the population proportion are satisfied. That will require that we should check if the answer for n times p at times 1 minus p at is at least 10. So let's proceed to check if this condition is met. So here is the check process. So to check, I'm going to grab the value of n times p at times 1 minus p at. That will be my n in this case is 2,318. My p at is 0.183, and then 1 minus 0.183, and in which case this should be equal to about 346.57, which of course is greater than 10, so the requirements are met. And then for question C, we want to construct and interpret a 90% confidence interval for the population proportion of adults in the country who have donated blood in the past 2 years. Okay, how do we do that? We can use technology, and so I need to take my x and my n, which is 423 out of 2318, and the 90% confidence interval into StatCrunch. So let's go there. So here we are in StatCrunch. I'm going to go to statistics, go to population stats, one sample, and with summary. And here, for the number of successes in my question, that will be x. X is 423, so that will be 423 out of 2318. Remember, number of observations will be the sample size, which we obtained here, 2318. And I'm going to need the confidence level, which is 90%. So I am going to click on confidence interval for P. I want 90%, 0.90. Leave this as standard word and compute. And I have my confidence interval is from 0.169 to 0.196. In this case, I am keeping to the convention to keep proportions to 3 decimal places. Remember, always read through the instructions in your question and round off to as many decimal places as required. In this case, the confidence interval is 0.169 to 0.196 if I choose 3 decimal places. So here I have completed the part of the question that requires me to construct. The next part is to interpret. So how do we interpret based on what we have done earlier? Here we go. So we interpret as follows. Based on the available sample data, we are 90% confident that the unknown population proportion of adults in the country who have donated blood in the past 2 years lies between 0.169 and 0.196. With that interpretation, we proceed to the next example. In this example, we are told that in a survey conducted by a reputable marketing agency, 247 of 1,000 adults 19 years of age or older confessed to bringing and using their cell phone every trip to the bathroom. Confessions included texting and answering the phone calls. Based on this information, we'd like to complete parts A through F below. A. What is the sample in the study and what is the population of interest? To begin with, the sample would be the 1,000 adults 19 years of age or older that were selected. Then the next question is, what is the population of interest? That is, what bigger pool did we select the sample from? As you might imagine, the population is all adults 19 years of age or older. So, what we have just said is what we have just penned down. All adults 19 years of age or older will constitute the population. Question B. What is the variable of interest in the study? Is it a qualitative variable or a quantitative variable? In other words, this means what characteristic of this group or this sample or this population are we interested in studying? I would argue that the variable of interest is bringing one's cell phone every trip to the bathroom. This is definitely a qualitative variable with two outcomes because individuals are classified based on a characteristic, whether they bring their cell phone on every trip to the bathroom or not. Let us write that down. So what we have just said is what you have here on the screen as what the variable is in the study and whether it is qualitative or quantitative and why we so decide. Then question C. Based on the results of this survey, obtain a point estimate for the proportion of adults 19 years of age or older who bring their cell phone every trip to the phone. The point estimate is the sample proportion. So the sample proportion, as we have illustrated earlier, is x all over n. That is, out of the sample of 1,000, how many have this characteristic, which is 247? This will be 0.247. This is the point estimate. Question D. Explain why the point estimate found in part C is a statistic. That is definitely because it is a numerical summary of a sample. That is, it's a characteristic value that defines a sample. Another way to say that is to say because its value is based on a sample. That is the reason why it is a statistic. Then next, explain why it is a random variable. It is a random variable because its value may change from sample to sample depending on the individuals in the survey. And then, what is the source of variability in this random variable? The source of variability are the individuals that are selected to be in the study. So let's write this down too. So, as mentioned earlier, the point estimate found in part C is a statistic because its value is based on a sample. It is a variable because its value can vary from one sample you select to another. And why will it vary from sample to sample? That is, what is the source of variability in the random variable. Its source of variability are the different individuals that can possibly be selected to be in the sample from one survey to the another. Then question E, we are to construct and interpret a 95% confidence interval for the population proportion. To do that, we need to take X and N and the confidence level to StatCrunch. So let's do that. So back in StatCrunch, I'm going to close this, go to Stat, and on the Stat, go to Proportion Stats, one sample with summary, and in particular, I want 247 out of 1,000. Take note that these two numbers, again, come from the question. X is 247, N is 1,000, and the confidence level is 95%. So I'm going to go to confidence level. This is already set at 0.95, so I don't need to alter that. And so I'm going to compute. And in this case, I have to 3 decimal places, 0.220 to 0.274. So the lower limit and the upper limit, I have taken the rounded off values to my working space. So this is the construction of the 95% confidence interval. And the correct interpretation would be that we're 95% confident that the population proportion of adults 19 years of age or older who bring a cell phone every trip to the bathroom is between 0.220 and 0.274. Question F. What ensures that the results of the study are representative of all adults 19 years of age or older? The key word here is random sampling. If the sample selected from this population is done in such a manner that we can guarantee that the units are selected without bias, then we can be sure that to a reasonable extent that the results of this study can generalize to the entire population of all adults 19 years of age or older. In particular, the answer, what ensures that the results of this study are representative? It is the random sampling process. With that question completed, we proceed to the next question. This example says that a group conducted a poll of 2,041 likely voters just prior to an election. The results of the survey indicated that candidate A will receive 47% of the popular vote and candidate B will receive 43% of the popular vote. The margin of error was reported to be 5%. The group reported that the race was too close to call. What does that mean? Use the concept of confidence interval to explain what this means. To use the concept of confidence interval to explain this, this is what we note. So for candidate A, they can receive 47% as a point estimate, but the margin of error is 5%. So that means minus 5%, this goes to 42%, and plus 5%, that takes us to 52%. Whereas for candidate B, we have 43% for candidate B. The margin of error is also 5%. So you have, let's do this way. Let's drag this a little bit, slide it down that way. So we have 43%, that takes us to 48%. And then for the margin of error of 5%, 43 minus 5, that takes us to 38%. So what you quickly observe is that there is an overlap between these two intervals. That means there's a possibility that they might get the same numbers. So for example, it is possible that they might both get 40%. If they both get 40%, 40%, then we know that this race is too close to call. So as a result, since there is an overlap, so because the poll estimates overlap, when accounting for margin of error, the polls cannot clearly predict the winner. So what we have just said earlier is what is here written on the screen. Because the poll estimates overlap when accounting for margin of error, the poll cannot predict the clear winner. This is how we use the concept of confidence intervals to explain what this means. So with that said, that completes that question.